resistance.
Okay, you ready for power? You got bars?
Yeah, but no tone.
Okay, we're ready. Where's the director? Let's go! Let's go!
Good morning. I'm glad you came this early morning, and I know it's really sort of a pain in the tushy to come in and for a sales training program early in the morning. I see you have lots of coffee. Make yourself at home. What I'm here for is to tell you a little bit about the Carver products and explain how they work and possibly answer some questions that you and your customers might have had during the course of this year. First, I'm going to tell you a little bit about the development of the magnetic field amplifier. Now, you're all familiar with this amplifier that has sort of been a breakthrough and an innovation because it's not very heavy for the output power that it provides. It weighs about 8 pounds. I first started to design this thing a long, long time ago when I was at Phase Linear. I used to come out in the morning and look at the assembly lines and see these massive amplifiers putting down the assembly line. And whenever I tried to pick one up, it would always sort of twist out of my hands. The power transformer was mounted on the left side. So I thought, gee, there must be a better way. Didn't think about it much until a few years later when there was a palace revolt and I ended up without a company. So I said, gee whiz, Bob, you really have to make a comeback. So I thought, what I need to do is design a better amplifier. One that's smaller, lighter, more powerful, better sounding, lots less expensive. I thought I could corner the market if I did that. So I thought and thought and thought and thought and thought. And the solution was very, very simple. The solution was a magnetic field coil, something like this small, this light. This little Hummer can put out 1,000 watts. This is a conventional power transformer. It's pretty heavy, and it can put out about 450 watts is all. The difference in size and weight is about 5.5 to 1, with a similar reduction in cost. And yet this is a better performer. Now, how it works is really quite simple. An ordinary power supply is activated all of the time. Red, please. Thank you. All of the time means 360 degrees. And this waveform is the waveform that's coming in from the power plug. Power plug. Now, if the power is applied all of the time to a conventional power transformer, it's very wasteful. The magnetic field coil has power applied only a small period. Blue, please. Thank you. Instead of 360 degrees, it's only about 20 degrees. Now that means that the input power is only delivered to the amplifier on an as-need basis, and the whole system can shrink down to a little cube just like this. The power is stored, no, not the power, the energy is stored in the magnetic field that surrounds this core. In a conventional amplifier, the energy is stored in large filter capacitors. and not at all in the transformer. The iron is totally wasted. The consequence is that when a bass note hits, the energy stored in the magnetic field instantly is delivered to the load. The device that controls this small time interval is this electronic switch, which is called a triac. Now that's the fundamental operating concept, that the energy is stored in a magnetic field and is available at a moment's notice so that the power can be delivered instantly to the loudspeaker. Are there any questions?
Why do we need all that power? What's the whole point of all that?
Okay.
Why do you make gigantic amps?
Well, I'll tell a story that happened to me a long time ago. I went to visit a friend of mine who was trying to reproduce the sound of a scissor snap in a real room and reproduce it realistically. And he said, "Bob, come on out. I've got the scissor snap that I'm reproducing, and I want you to take a look and take a listen." So I went over to his house, and he had 24 400-watt amplifiers lined up on his shelf, trying to reproduce the snap of a scissors. And the reason is that a scissor snap, although there's not much energy in it, has a tremendously large peak energy content. And for that moment in time that peak was required to be reproduced, all of the 24 amplifiers were activated almost to the hilt. Now that's an extreme case, but it gives you an idea that if you want to reproduce musical transients, musical peaks, the tremendous impact of a kettle drum, realistically, or the whap of a snare, you really need lots of power to avoid clipping and overload. Without it, the amplifier will clip, the amplifier will overload, introduce harmonics, introduce distortion that will ultimately result in listening fatigue. It's not to play sound louder, it's to play sound with greater purity. That's why I've always been interested in large power amplifiers. Julian Hirsch wrote 10 years ago to the day, he wrote, when he reviewed my original 700-watt amplifier, he wrote in the conclusion of his review, "You know, gee whiz, we wonder if 700 watts is enough." And the reality is, it's not quite enough. It really won't do it. Well, that's all well and good, but I know that many of your customers would prefer to have a more conventionally shaped amplifier. And so, the new Carver M500. This amplifier is a magnetic field amplifier rated at 250 watts per channel and does about 350 watts RMS for brief time periods. And as you can see, it's shaped more conventionally. It also has infinite resolution meters, which are very, very, very accurate, as opposed to the dancing LED display on this amplifier. These provide a nice light show, but realistically, they're nothing more than that. On this amplifier, you get precision output metering. So the difference between an infinitely variable VU meter and a bunch of lights the accuracy is not related to how fast they are, but rather it's related to how fast the circuitry makes them move and how accurately they move and hold, give you time enough to see it and then for it to decay. The meters have infinite resolution. The LEDs have discrete steps. So an LED has to be somewhat ambiguous, depending on which one lights. So the meters are better, they're more accurate, and in my opinion, I'm sort of a softie for meters. That's why I put the meters on. Back in the laboratory, we're working on a 1.5 amplifier. It'll put out 750 watts per channel for brief time periods. I'm not going to tell you too much about it, but I'll tell you this much. If I died tomorrow and went to heaven, I would feel that my life's mission is accomplished, because this is an amplifier I've been working on and dreaming about and thinking about my whole life. You think these things are neat. This one will knock your socks off, the M1.5. May I have an erase? Black, please. Thank you. I'm going to talk about sonic holography. Why sonic holography? All of us know that stereo sound is an illusion. And it's an illusion that is so fundamentally flawed that any 6-year-old could not be fooled into believing he were listening to a real live performance if he were indeed listening to a stereo playback system, no matter how good, no matter how wonderful. And the reasons that it's flawed are fundamental ones, related to how we hear sounds. Imagine a sound in real life. Real life. I'm going to show what happens when we listen to a sound in real life that's dead ahead. As I said before, sound flows across space to this ear, sound flows across space to this ear, and it arrives simultaneously. You notice that for a single sonic event, 2 sound arrivals occur at our head. One event equals 2 sound arrivals. And that is real life. Now, let me play that back in stereo. Red, please. If I have a stereo loudspeaker here and here, what happens is this. The stereo speaker will emit a sound which will flow across space to this ear, simultaneously flow across space to this ear, flow across space to this ear, and to this ear. Now, watch what happens. The first sound to reach this ear is the sound that travels along this path. And the first sound to reach this ear travels along this path. They arrive at the ears. They're equal in amplitude, and our interaural amplitude center in our brain, called the IAD center, says, aha, equal amplitude sound dead ahead. And for a tiny fraction of a second, everything's just fine. But by and by, the sound from this speaker arrives at this ear. About 100 microseconds later, 100 millionths of a second, and all of a sudden, the ITD center in our brain has received 4 arrivals, 2 per speaker per ear. And it says, aha, sound not dead ahead, 2 separate sounds located equidistant left and right at the loudspeaker location. And confusion reigns. Now what happens in stereo, obviously, or stereo wouldn't work at all, is that our IAD center is somehow beat into submission. No, the ITD center is beat into submission, and the IAD center says, well, the sound must be straight ahead. But what happens is it's sort of smeary, it doesn't sound realistic, and you really have to suspend your disbelief to believe that it's a sound that bears any resemblance to real life. So stereo is like this. One event equals 4 sounds. That's stereo. Sonic holography, very simply, restores the proper timing cues so that you can hear the timing information that exists in the recording in an unconfused way. And it does it simply by canceling, via sound wave interference phenomena, the 2 unwanted arrivals at this ear. May I have a green, please? No, give me a blue. I need a blue. Thank you. And it does it in the following fashion. Remember that the sound that arrives at this ear from this speaker is an unwanted one. So this loudspeaker launches a third sound wave, a holographic interfering sound wave that meets this sound wave and causes it to be canceled. And this one, this loudspeaker, launches a similar sound wave that travels along this path link, reaches the area here at your ear, and cancels the unwanted one. So, after all that is finished and done with, the only sound arrivals you hear will be sound arrivals as if they came along this line. The result is a set of sound images in space that are completely divorced from the position of the loudspeaker. The sound stage is wider than the loudspeakers, deeper than the loudspeakers, in front of the loudspeakers, higher than the loudspeakers, and lower than the loudspeakers, except the floor is usually in the way. It's an illusion that is so much better than regular stereo that once you've listened to it, once you've got it set up properly, and oh, I know, it's a pain to set it up. I mean, it's a real pain to set it up, especially in a floor that's got a lot of traffic and you're moving stuff. It's hard. It's possible to have many listeners listen to holography at once, but they have to sit behind each other, like this, or in front of one another, not side by side. I'm going to give you an extreme example of what holography can do. Imagine somebody whispering in my left ear. Now, what happens when someone whispers in your left ear is that you hear the sound in your left ear only and not in your right ear. So it sounds like it's coming from your left ear. Now imagine a recording made of that whisper in my left ear. Well, the best a stereo system could do would be to play back that and have the whisper come out of the loudspeaker. Pretty preposterous. It's very spatially distorted. Not so good. What the hologram would do is it would make the sound seem to come from my left ear. It would move the sound from the loudspeaker to my left ear. And it would do it by canceling the inappropriate sound that arrived at my right ear from the left loudspeaker. Now that's the extreme power that holography has. It can move a sound any place in space. You can see that if it can move it to my left ear, it can move it in space anywhere. The Carver C4000. Now, what I did when I designed this preamplifier, I put everything I could think of in it, because for two reasons. One, it needed it to really do a good job, but also I wanted to just drive the competition totally down the drain. So it has a set of features that make it a complete control center standing alone. It has bass controls, separate bass, separate treble controls, tone defeat switch, tone turnover switches. See, I'm going to have to sort of look at them. It also has a muting switch, stereo mono switch. It has facilities for copying tapes from one tape recorder to another. And it has dubbing facilities so that you can go to the first tape recorder or back. It has an external processor loop. And in addition to all of the normal features found on a preamplifier, it has several things that make it stand above all the competition. It can create a sound illusion that is truly dramatic. It has the Sonic Hologram generator that I've outlined here for the front half of the sound field, for the frontal hemisphere. Erase, please. Blue, please. When we're listening to a live performance, the sounds we hear are made up of direct sounds and reflected sounds. The direct sounds are the ones that holography is interested in. The direct sounds are those sounds that give us the sense of image location. inside of an acoustic space. So I'm going to draw many images here in space. Inside of these dotted lines operates the Sonic Hologram generator and Sonic Holography. However, what I haven't shown, and something that's important to our perception of sound, are the reflected sounds, the reverberation components that are related to the hall that the sounds occur in. Without those sounds, the music will sound flat, dead, and not particularly lifelike. So we need something to tell us not only where the sounds are in space, but we need some auditory cues that tell us something about the space in which the performance occurs. Now, when you play your hi-fi in your living room, you can tell you're playing your hi-fi in your living room because your ear brain centers are working properly and telling you a great deal about your living room. That's okay as far as it goes. But what we really want to do is add a perspective that says concert hall. To do that, we have to pay attention to the longer delayed sounds, the sounds that arrive many, many thousandths of a second later. Not millionths of a second, which is the holography, but thousandths of a second. Those are the reverberation and reflected sounds. And these come basically from the side and from the rear. They also come from the front. But they're delayed in time so much that those sound arrivals tell us about the hall, and that is accomplished in this unit by a built-in time delay system. Moving right along, that's not the end of it, though. So this preamplifier has given us Sonic Holography for the front, has given us time delay and a built-in power amplifier for the delayed and the reflected and the reverberant sounds. But still there's something missing, and that's dynamic range. When a recording's made, typically, when a snare drum hits, the recording studio can't possibly put that on the record. So they have a compressor that clamps its level. Just momentarily clamps it. But it results in something that's not really like real life. This preamplifier has a peak unlimiter, which in large measure undoes that limiting effect that the recording studios superimposed. In addition to the peak unlimiter, it has an autocorrelator noise reduction system. When a recording studio records the distant wail of a French horn, it sounds distant and it's truly wailing and it's very soft in real life. But when it's recorded, the recording engineer must of necessity pull the volume level up so that the French horn is too loud and is not a distant wail. The autocorrelator removes that noise, and the peak unlimiter pushes the level back down where it belongs. So the dynamic range is expanded by almost 20 dB when you use the autocorrelator and the peak unlimiter. So taken together in total, the Sonic Hologram generator for the front hemisphere, the time delay for the rear hemisphere, the peak unlimiter to undo the damage that the studio limiter has done by chopping off the peaks, and to restore the pristine signal-to-noise ratio, the autocorrelator pushes that noise floor down. All working together, properly set up, is just an awesome experience. The C1 preamplifier is our latest product and is $550. Now, there aren't very many $550 preamplifiers in the market that do a perfect job in handling the signal from input to output. There are some, but very, very few. I've spent a lot of time in the design of this system, of this C1, so that the output of the preamplifier is an absolute replica of the input to the preamplifier. In this case, for every 1 watt of output that the amplifier would be playing, there is this many watts of distortion. 0, 0, 0, 0, 0, 0. 6 zeros. To put that in perspective, this tiny difference is below the thermal noise floor of our hearing mechanism. This is such a small power level that the mechanical impact of air molecules on your eardrum in a perfectly quiet room makes lots more racket than that power level does. It is below the thermal noise limit of your hearing. It is below almost the thermal noise limit of any piece of electronics. Now, we're very proud of this achievement. And that's treating it only as a straight preamplifier. Add to that the Sonic Hologram system, full feature tone control system, and the option of putting the tone controls in or out. And you have what I think is one of the best preamplifiers that you can buy. We've gone beyond that. We've included a moving coil preamplifier stage in this unit. A magic thing happened in this unit. Motorola, bless their hearts, came out with an amazing transistor this year. It is absolutely astonishing. It has a noise floor that's within 1 dB of the theoretical noise floor for 10 ohms. Now that's an achievement, not for 47K, but for 10 ohms. So what I've done is I've taken that transistor and I've made a phonostage out of it. A phonostage with lots of gain. An extra 24 dB of gain. So you have, in this case, I've got my cake and I have it to eat at the same time. It has 0 phase shift because it's an active system. It has a perfectly flat frequency response. It won't saturate at low frequencies. It's absolutely linear, absolutely a straight line linearity. And yet it's quiet. It's as quiet as the best moving coil step-up transformers because Motorola has somehow figured out a way to make a transistor do that. As far as I'm concerned, it's black magic. But I don't need to know why. I do know that it works. So, going back to my last statement, the best moving coil step-up device is no step-up device at all is true in this product. It doesn't have one because it's just a high-gain phonostage. The C9 is a product for your customers that already have a system and want Sonic Holography. Now, there's an opportunity to really make some sales with this device because it's not very expensive. It's $275. And a lot of customers might live in a small apartment and have small speakers. And they would think that, well, I can't use holography because my room's too small. Not so. I have a dealer in Los Angeles who used to sell about 2 or 3 of these a month. And he's got this really hot dog demonstration, and he rolls them out now about 1 a day. I mean, it's just something to see. And what he has is a little rack that's about this high and 2 foot pads glued to the floor. Just white foot pads, look like feet. Come up, stand on the foot pads, hit the button, and all of a sudden, this giant image. And everybody buys it. For component systems that have separates, for component systems that are receivers, integrated amps, even some people that have cars, because you make tapes. You can make holographically encoded tapes with this device, as you can actually with both preamps. And it'll play back on your car system in holography. Any questions?
Yeah, Bob, I was going to ask you, there's been a lot of different image enhancement, spatial enhancement devices that have hit the market since you initially brought them out, and wondered what really the technical differences are between things like biphonic sound, spatial expansion, compared to like your holograph circuit.
The answer is this: they differ a great deal. None of them generate a canceling signal. Let me show you what the differences are. Now, there are 3 important elements to sonic holography. One of them is interaural time delay. The other is invert. Invert simply means that the cancellation signal is a true cancellation signal. It's inverted, it's upside down, so that when it combines in space with the unwanted signal, it vanishes. They both vanish. The other property is that it have associated with it something I call, an engineer would call, crossfeed. It's fed from one side to the opposite side. Now these are the fundamental features of sonic holography. Each one is necessary to produce a true cancellation signal. Instead, what happens with an omnisonics is that the delay that has to be there is a random one that's associated with random delays on the records. And so the images that are produced will be frequency dependent, and if a violin is playing, the low frequency components may be here, the mid-range components may be over there. It's sort of neat, but it's not like real life. Now, another imager on the market is the biphonic. I believe there's a PH in there. That's good enough. And it does an invert a crossfeed and a phase shift. So, without an interaural time delay, again, without the interaural time delay, the signal can't be canceled at your ear. It's merely a phase-shifted signal. So the spectral, your spectral perception on a system like that is different than your perception with sonic holography. This concludes the presentation, and I want to say thank you very much for allowing me into your lives today. And remember this, take these products and go out there and rake it in. I would like to take this time to say thank you to lovely Miss Hologram and my constant companions.